Hi, this is Ms. Schultz's class. Hello, it's me. This is Ms. Schultz taping this for AP Calculus at Boston Collegiate Charter School, and we're going to talk about graphs where you have a function that you can't see defined as the integral of f whose graph you can see. All right, and you're going to watch this on your own. All right, the figure above, let's talk about this first one. The figure above shows the graph of the piecewise linear function f for from -4 until 12. The function g, which we can't see, is defined as g of x equals the integral from 0 to x of f of t dt. A, does g have a relative minimum, relative maximum, or neither at x equals 10? Justify your answer. So for these questions, as I always suggest, you want to justify first. So we want to say these would happen if g equals 0 or d and changes signs. Okay, I'm not going to write signs because I'll figure out if it changes from positive to negative or negative to positive or neither and write that in. So let's see. So the point, oh, it's g prime. It'd be g prime. So the point is I need to find g prime. So if g equals the integral from 2 to x of f of t dt, g prime is going to equal, this is fundamental theorem of calculus case 2, the derivative of an integral. That's the fundamental theorem of calculus case 2. When you are given an integral and you're taking its derivative, that means you substitute in the top, just as simple as that, f of x. If this top were anything other than x, let's say it was 2x, then, or x cubed, something like that, sine x, anything, then the chain rule would apply and you'd have to multiply by the derivative of the inside. But of course, that's not true. So f of x is as simple as that. All right, so now let's look at f of x. So this now becomes f of x, this statement up here becomes f of x equals 0 or d and changes signs. I'll write signs there. And changes signs. Okay, so now this is great. I have a statement about f of x who I can see. Great. So, and then it says at 10. So at 10 here, all right, does it equal 0 or d? Yes, it equals 0. Does it change signs? No, it does not. It goes from negative to staying negative. So neither, because f of x, so you could say f of x or you could say g prime. So you could say f of x or you could say g prime of x doesn't change signs at 10. Okay, so that's A, all right? You can pause the video if you need more time to write that down, but I'll move on. B, does the graph G, again it's asking about G, which is defined as the integral of what I can see, have a point of inflection at x equals 4? So G, having a POI, point of inflection, would mean G double prime equals 0 or d and changes signs. Okay, so my question is, what's g double prime in terms of f? If g prime is f, let's just write this. So if g prime is f, so g equals the, let's just make a little chart here. I think I'll make it on this side actually. No, I'll make it here. If g equals the integral of f, g prime is just equal to f. Okay. G double prime is equal to f prime. Okay, so this is a chart that we should get familiar with for these problems. So g double prime equals 0, changing signs. I'll translate this problem to say f prime equals 0 or d and e and changes signs. Okay, that's actually literally my justification for point of inflection. So at 4, let's look at 4. Does it equal, does the derivative here, so I'm talking about the deriv here, does that equal 0 or d? Question mark? Yes, it does. The derivative there is undefined. Yeah, so I'll just scratch that out. So in this case, f prime does in fact equal 0 or DNE. And does it change signs? Yes. So f prime does in fact equal DNE. And it changes, the slope is positive over here. So f prime is positive. And here, f prime is negative. So f is positive and f is positive. But we're not talking about f. Remember, we're talking about what is f prime doing for g to have a point of inflection. And it's changing, from increasing to decreasing. Okay, and stay tuned for the next video.
Wait.